All right, so this is for example 2b.7. You are given theta equals 45 degrees, phi equals 30 degrees, L equals 0.6 meters, and VB equals 2.5 meters per second. We are supposed to find the angular velocity of the bar AB and the velocity of A and the velocity of point G. Here's A. G is this dot right here. Hopefully you can see it. And well, that's VB and that's given. So this diagram, this amazing artistic rendition, this is the bar that we're finding. These are the rollers, and this is, well, the thing that they're on. This is the angle of this bar, or the ramp, which is 45 degrees. This is the angle of the bar at its current position, which is 30 degrees. And then, to find the instant center, they basically find the velocity of the direction of each of these points. VA is going up to the right at a 45-degree angle, and B is going straight right. So, a perpendicular line off B goes straight down. Then you take a perpendicular line of the velocity of VA. It'll meet about here, wherever here is. That is the instant center of AB. And using that, use some fancy triangle magic, and you get this. So you have L sine of phi, which is for this section here, and you have D sine of theta, which is this length here. This line here is equal to D, but D's not given. And that's how, well, you solve for it using these equations. And then this line is equal to L cosine of phi, and it's also equal to D cosine of theta. And using that relationship, we're able to make all of our calculations to find everything. Now, to find D is equal to L cosine of phi over cosine of theta, which is basically how it's written right there. Now those values come out to be D equals 0.6 cosine of 30 degrees over cosine of 45 degrees, which comes out to D equaling 0.735 meters. Now with that, we can now solve for the angular velocity of the bar AB. So WAB, or the angular velocity of AB, is equal to the velocity of B over L sine of phi plus D sine of theta, which will come, and that's the K vector. It's omega, right? Yeah. So omega AB is equal to 2.5 over 0.6 sine of 30 degrees plus 0.735 sine of 45 degrees, which comes out to omega of AB is equal to 3.05 radians per second in the K hat.
Next, we're trying to find the speed of A, and to do that, we know the relation of VA and of omega AB and D. So VA, the speed, equals D times omega AB. So therefore, we can use the value that we just found of omega AB and D, which we found right here, and plug those in, which would become 0.735 meters times the 3.05 rads per second, and that speed would come out to be 2.2 meters per second. Then next we try to find VG, and we have the relation of VG to VB, which is a given, of VG, the vector of VG equals the vector of VB plus omega AB cross the difference in position of G and B, or the position of G with respect to B. And from there we can plug in the values for VB, which would be 2.5 meters per second I hat, as there's no velocity in the y direction. And then we can also plug in our omega AB, which we found up here, which would be 3.05 rads per second K hat cross. And then to find our position of G with respect to B. This over here is a kind of like cross section of this. It's just like a cutoff section. This is your point G right here. And then this is your bar AB, and this is the ramp that it's on. So from the diagram, we can see that G is placed at L over 2, which is just the length in half. This angle right here is the same as right here, which is phi. And then what you do is you make triangles again, and you would use this as the hypotenuse. So this lower side would be L over 2 cosine of phi. And then this other side would be L over 2 sine of phi. And that gives you your I hat and J hat direction or positions. And from there you can plug those in. So we have negative because it's with respect to B, so it's to the left, and our coordinate system is like this. So it'd be negative L over 2 cosine of phi I hat minus L over 2 sine phi of J hat. And from there we can do our cross multiplication. So we would get, from this, we would get negative because K times I is positive, but it's already a negative value. So we get negative 0.7925 J hat. And then with this value, we have a negative, but it's K times J, which would turn out to be a negative value. So that's double negative, so we would have positive 0.475 I hat. Then from there, we combine our I hat values, so we get 2.96 meters per second I hat and negative 0.7925 meters per second J hat. And then because we are trying to find the speed of VG and not the vector, we would take the magnitude of that. So we would do the square root of the I hat value squared plus the square of the J hat value. And so VG, the speed, would come out to be 3.06 meters per second.
I think that does it.